In this video, I'll be taking you through all of the questions related to a coast investigation, and this is for paper 4, Cambridge IGCSE Geography. The purpose of this video really is to provide a breakdown of the exam paper and how to approach each type of question. I show you examples going back for a few years, but really it's mainly focused on the methods involved in carrying out a coastal investigation. So because of that, the mark schemes I show you would provide useful language and points to consider if you are writing a piece of coursework on a coastal investigation. And like I said, it's really impossible to cover every aspect. I didn't go through every single exam question on coasts. I just wanted to pick out the key elements of when looking at a coastal investigation, because really every single one there is just slight differences. And so here I've just drawn your attention to the key aspects and particularly focused on coastal investigation data collection methods. So please do use the chapters in the descriptions to wind forwards, to move forward to different parts if you are completing a past paper or writing a piece of coursework. So how to use this video? Really, I would have a past paper out in front of you. You can find them online. It's not too difficult to do. Have a go answering it and use this video if you're unsure. I've put all the chapters into the various parts. So have a go first if you're unsure, wind forwards to or wind back to a particular chapter, watch the video, play, pause, rewind, then have a go yourself, making sure that the points I put on the screen you incorporate into your notes. So introduction style questions. You should know that for an alternative coursework paper, it's still heavily based on, it's still structured as if a student was writing a piece of coursework. So you would have about 12 marks stretching across 2 questions that look at asking you about how to write a hypothesis or related to some geographical theory. So here are some hypotheses from a variety of past questions. Pause the video, take a moment to read through them, just so you can refresh your mind about what is a hypothesis, what is the key characteristics that sort of unify each one, and what do we have to do with them. So what are hypotheses? Hypotheses usually do one of the following. They make a statement. I predict something is going to happen. They might compare 2 locations. I predict that this location has a higher amount of erosion than this location. They might also state how something will change the further you go along a transect. So the beach material will get larger the further away from the sea. So you expect your hypothesis to be true. If they are false, it is the opposite. Now, when looking at these questions, if you are asked to write a hypothesis about an investigation, have a look at the exam paper, go through it, because they might actually give you they will give you a refresher of how to write a hypothesis that you could use to write one about coasts. But remember, these are what hypotheses are. They either make a statement, they either compare 2 locations, or they state how something will change. So some basic theory associated with coastal processes. If you know this, please do wind forward to the data collection methods. If not, please go through each individual part. So the first bit, waves. Now, we should know that waves coming up the beach are at an angle of what we call swash. The waves that come back down the beach is referred to as backwash. There are 2 types of waves, constructive and destructive waves. Constructive waves, think about when the sea is calm, the waves are really small. Destructive waves, pretty much when there's a storm going on. Huge waves crashing against the cliff. So because of that, constructive waves really, they deposit material, they don't do anything to the beach. If anything, they grow, they make the beach more stable and they help to grow the beach. Whereas destructive waves, as their namesake says, destroy the beach. Huge energy, huge power, destroying the beach. Now, please pause this video and make a note of the various characteristics. How do each compare? Because this is incredibly useful for paper 1, paper 2, and for this paper. So these are the type of questions that might come up. For example, to tick the box that refers to what is a constructive wave, so I might tick this one, and for the last one as well. Here we go. 2 nice simple marks. Likewise, describe how constructive waves are different. So for 4 marks, you might state something like constructive waves have a strong swash and a weaker backwash, whereas destructive waves are the opposite. Constructive waves are low in height and have a lower frequency of 6 to 8 waves in minutes, whereas destructive waves are taller and are more frequent. So, nice straightforward question. Describe how destructive waves and constructive waves are different. Literally, compare the 2. That table from the previous slide. And for the final point, constructive waves tend to deposit sediment on the beach, destructive waves erode the beach. So if we look at the mark scheme, really nice, pause the video, all the various characteristics about how destructive waves differ to constructive waves and provide you really nice statements that you can write for an exam question. Like I said, this exam question could appear in a paper 1 or in anything in paper 2. So as you see, very clearly, in simple statements, I could tick all the boxes. Now this one slightly changes, explain why destructive waves erode beaches and constructive waves deposit material. Destructive waves have a greater backwash than swash. There is more energy to drag material back down the beach and out to sea. As well, these waves have a higher frequency than constructive waves, so there are more waves crashing onto the beach, increasing the amount of material being removed. So again, we check on the mark scheme. Yeah, ticking all the boxes easily. So again, pause the video, include those into your notes, because it's again a very common question that could appear in any of your past questions. And if you're writing an analysis, again, this might help you to explain why, if on the day you are measuring wave frequency and there are more destructive waves than constructive waves, why that might explain a difference. Other geographical theory you might be asked in these questions are erosional processes. So here I've got a nice question that just sums up, that gives you a key definition of each one. Please do remember this by heart. Really useful for rivers. If you just replace the word waves with rivers and any other parts of the riverbank with cliffs, really useful for learning these definitions, because they do come up across multiple exam papers. So again, just match the terms here, and then explain why erosion is taking place at X but not at Y, linking to coastal management, so we can see at Y there are groins which are encouraging sediment to build up, protecting the coastline, whereas at X the coastline is exposed, so more susceptible to erosion, hence the wave cut platform. Remember, coastal defences are there to defend the cliff from erosion. So look at the mark scheme, yeah, ticking all the boxes nicely. So other processes you're expected to know is longshore drift, really important when it comes to coastal management. So nice question here for 4 marks. Again, this could appear in paper 1, paper 2. Describe and explain the process of longshore drift, which is shown in figure 2.8. Here we go. Now the only thing I would add before figure 2.8 is the arrow for swash and backwash, because this is again another two key terms which should appear in a longshore drift answer. And so I would add that on just to remind myself, okay? So when asking this, all the information you've got is there. You just need to think about what is happening in this picture using the keywords that have been provided for you. So longshore drift is the movement of sediment along the beach, and it occurs when? Nice opening paragraph here. That should at least get you 1 mark. The swash carry materials onto and up the beach at the same angle as the prevailing winds. Again, using the key terms from the diagram. Due to gravity, the backwash pulls the sediment back down the beach in a direction that is perpendicular to the beach, and the process is repeated, which means that sediment is carried along the beach in a zigzag direction. Look at the mark scheme. Ticking the boxes there, and again, looking back on the front, nice simple explanation that you could use this actually for a 7-mark response if you're having to explain the formation of a coastal spit. But this neatly sums up for you the process of longshore drift. And again, another common question, you might have to tick 3 statements that are true about or correct about longshore drifts. So we talked about is the movement of material up and down the beach, the prevailing wind is the key influence, and it's all about waves approaching the beach at an angle. And so again, check the mark scheme, and away we go. And again here, common questions that you can see in paper 1, paper 2, identify a landform from a photo. So you can see here that for this one, we would be looking at headlands, and again, it's there. So what I'm trying to show to you is this showing you how that paper 1 and paper 2, everything that you learn for those 2 papers really does make a difference when looking at this piece, this exam paper. 12 marks are at stake here, stretching across 2 exam questions. So please do remember that the revision you do for paper 1, paper 2 trickles down to paper 4. And here I've just provided you with some nice photos of other coastal landforms that you need to be aware of and about what they look like. So headlands and bays, coves, crack cave archstack stumps, tombolos, bars, etc. Okay, so please do make sure that in your revision notes, paper 1, paper 2, you know exactly what these look like from a photo and on a map. Now you can see on your screens, this is a definition of coastal erosion, the wearing away and the removal of the coastline. And so when it comes to coastal defences, we need to do one of 2 things. The first thing we need to do is slow down the wearing away or prevent the removal. And so there are many different methods that enable us to do that. And these methods are on your screen. Again, you need to be aware of, I haven't given you the notes for this, but you need to be aware of what each one is, how each one works, and the various strengths and weaknesses of using each one. Now, the one I'm going to particularly focus on in this exam paper is groins. It's appeared on a variety of past questions. So again, just make sure and pay attention. So here you can see some of the questions. Figure 2.2 shows one of the groins. Describe the groin. So we can say that groins are generally made out of woods. They extend from the shore out to the sea, and they usually run perpendicular to the sea. And we tend to see groins on a pebble beach. You might see them on some mixed sediment beaches as well. And again here, you can see the various characteristics of what a groin is. So moving on. Other questions that come up as well: explain why groins are built on the beach, describe the groin, and explain how it can reduce the effects of longshore drift. So again, I've just left this on your screen. Pause, make sure you add these points into your notes, because again, it's really important, because this has appeared, as you can see on the screens, multiple times as a method that is used often in a coastal investigation. Final one, sand dune formation. I've seen this done in a variety of ways, but this sums up nicely with this question, which again can appear in any paper 1 or paper 2 past question, exam question. Explain how dunes like those shown in photo A, are formed. So very key characteristics: sediment like sand is blown by onshore wind onto the lands. If there is an obstacle like a rock, this blocks the wind and sand is deposited and built up around the obstacle. Over time, as the sand builds up, vegetation like marram grass might start to colonize and stabilize the dune, making the dune grow more. So again, you can check out the mark scheme, ticking all the boxes there. So please do pause the video and include these notes into your revision. These are the exam questions that are perhaps unique for this paper, that has the unique content that you need to learn pretty much off by heart to help you approach these questions. And like I said, having gone through previous past questions and done videos on those, I wanted to focus on common marks that appear across multiple past papers. So what I've done is, for example, I've looked at how you measure the beat profile, and I've pulled out from multiple mark schemes the key content you need to know to help you write that perfect answer that will get you the full marks every single time. So for this chapter, I'm going to start looking at types of data and sampling and pilot studies, why we do those for coastal investigations, and then common risks that come up for coastal investigation before describing the methods. If you know this, there's lots of similar content to what I've done in other videos. Please just wind forward to maybe risk assessments and describing methods for coastal investigations. If not, just slowly work through this part of the video. So types of data, primary versus secondary. Really the key thing to note about primary data is that is observations that you have gone out and collected. Okay, so you've prepared an investigation, you've decided the methods, and you've gone out and collected the data, whereas secondary information is pretty much data that's already been collected. For example, it could provide you with tidal information, it could provide you on past investigations in that particular beach, and other studies as well. So that's the key difference. Now, I have seen 1 or 2 past questions that have looked at questionnaires, have used questionnaires, which is typically a method associated with human investigations. Please, if you want to find out more information about those, check out my other videos that will be that you can see on my channel. But until then, there's some types of data that you need to be aware of. You've got qualitative versus quantitative. So quantitative data is data counting the amount of fixed responses or taking specific measurements. So you look at something and you choose from a fixed response, whereas qualitative is pretty much just you've asked people for their opinion. Okay, so it's a lot more unique data that you maybe have to pick out some key themes. So again, pause the video, look at the differences between qualitative and quantitative and add them to your notes. So something that is massively important for any investigation is making sure that you have sampled and you've chosen an appropriate number of sites. It's impossible for you to do a study along the whole length of the beach. That would just take far too much time. So you do a sample, maybe identify a transect of a series of sites to enable you to make sure that the data you collect is representative of that whole beach or beaches. So how will we do this for a coastline? Really, we can do 3 main methods. You've got stratified sampling, systematic sampling, and random sampling. And if you know about this, again, pause the video, skip this. If not, please stay and watch. Systematic sampling is where you take observations at regular intervals, e.g. you ask the 5th person or every kilometre here. So imagine these are people, right, 5th person, I'm going to stop and ask, so on and so on. And likewise, this could be a beach that's 20 kilometres long, and every kilometre you are stopping and collecting some information. Next one is random sampling, where pretty much you just choose, use a computer model or whatever to randomly select sites. So in this particular case, I've just chosen people that to be able to stop and ask. If not, on a beach, you might just say, right, I've got various differences. I use a computer model, and whatever distances along the beach they choose, I will collect, stop and collect my data. Or you've got stratified sampling, so you divide up the beach into various sections, and then you plot maybe a particular point within that. So really with beaches, I haven't seen too many questions about how you go about sampling particular locations. They tend to be more about, they give you those sites. Most of the time it's talking about the risks associated with selecting those sites. So when it comes to any study location, these are the key ones that you need to be aware of. You know, if it's too hot, too cold, what happens if the weather changes, the tide, could you slip on rocks? Could you get some illnesses from, I know, drinking seawater? What about the time of day? Could you get lost? Or how accessible is that particular part of the beach? Are there any other risks associated there? So let's start looking at the questions that bring together sampling sites and risks associated with that, and how that affects your decision. So here, this is actually a straightforward sampling question. Describe a sampling method to collect 10 pieces of shingle at each site. Refers to the equipment students could use. This is 3 marks. Well, really, you can see here, they've split up this part of the beach into 15 separate sites. And so how would you go about collecting that at each site? Well, I just wanted to talk about why did they select that stretch of beach? Well, maybe because on towards the west of the beach, the southwest part of the beach, perhaps it was too dangerous to access. Perhaps it was high cliffs that might have led to a fall, and this was the safest place to locate. So back to this, how could you refer to the equipment students could use? Well, really, there are lots of things you could do. This mark scheme is actually really interesting to know. They've got 3 different methods. What I find actually quite interesting is the bottom one. Pick up 10 pieces of shingle at random. You know, the way I read this mark scheme, the way I looked at this, I think that's enough to get you 3 marks. You could do that. You could go to each site. You have them already labelled out, so you could talk about, you know, at each of the 15 sites, in the centre, randomly pick up 10 pieces of shingle. That is enough to get you 3 marks in my book. There's 3 different methods here, so again, you might want to think about each one and include those in. So other ways that you can look at some questions, really interesting questions I've seen about looking at how to plan your field work, which I think is more associated with coastal runs all the way back from 2016. Hey, look at tides, okay? That's the question, is what date and time is the highest tide forecast? So again, when there's high tide, the beach is going to be covered. When there's low tide, more of the beach is available. And so for this question, I would highlight all of the rows that have H for high tides, and then identify the highest one. So we've got Monday the 6th of June at 24 minutes past midnight. Saying why do students need to study the tide whilst planning fieldwork? Well, safety, you could get stranded or cut off from the mainland. And then when the beach is at low tide, you have a much larger study area to work in, So again, think about it, think about what a tide means. The beach is covered, so that's quite dangerous. You could be dragged out from tide, you could be cut off. Obviously, there's less beach for you to work with. And the next one here, look at the figure 2.2, which time is their forecast with the highest temperature, strongest wind and least cloud cover. So you need to look at high numbers. And so we go to the one at 3 o'clock. Yep, okay, correct. And then give 2 advantages studying the weather forecast when planning field work. Well, again, if you're in storm conditions, there's going to be a storm, there's going to be very strong waves, that could be dangerous. That's why you could get cold. So these are all the various points here. So again, I put the mark scheme here just so you guys have got nice points to consider when considering about tide for coastal investigations and about how to reduce risk. So we just double check. Yep, all correct. So moving on. Other questions associated with risks and how that can influence your site selection. Well, here we go. They've done an assessment of the likelihood of a risk from happening, the severity if it does happen. And when you multiply those two together, you get the actual risk factors. The higher the number, the higher the risk. So nice one here. And this is explained neatly underneath the table. So again, read the whole table to work out how to interpret this table. Which one of the possible hazards did students think was the greatest risk? Well, which is the highest number? Hypothermia from getting cold and wet. I wrote out the whole of that fact hazard, so please make sure you do. And then if we're looking at the different ways to reduce risk, cliff collapse, well, quite straightforward. Don't walk near a cliff or don't work underneath a cliff or wear a hard hat. Hypothermia, well, warm clothing. Getting lost or isolated, stay in a group, have a mobile phone. Look at the mark scheme, all the various points for you to consider. So again, when you're planning this, when you're making your notes about risks associated with coastal investigations, please do include these in there and how you go about minimizing it. So again, with these questions, it's quite hard to find ones that talk specifically about sampling. 9 times out of 10, you create a transect and you do a study along that transect, which we'll go into a little bit more about what a transect is when we look at data collection methods. But really, it's about, you have a stretch of coastline, you divide that up into maybe every systematic sampling, you collect data every kilometer along that beach, 100 meters. And then when you're at that site, at that particular part of the beach, is how you go about collecting data from there. You might need to construct a transect or just randomly pick up sediment. And then what influences your choice of sites are the risks involved. So please have those very clear in your head. Now, unless I've made a mistake, I haven't actually seen a question associated with why you do a pilot study for coastal investigations. So these particular questions I've pinched from the river investigation. But just to recap what a pilot investigation is, it's done before the main investigation. Basically, it enables us to identify, can a full-scale study take place? Are those sites safe and accessible? Are additional costs and resources required? And it enables the person to familiarize yourself with the methods. Okay, so these are all the various things about why we consider a pilot study for coasts. And then this is a question again taken from rivers, and these are the various points that you can about what a pilot study is and the reasons why we do this. So again, include those into your notes. And likewise here, a follow-up question is, 2 advantages of doing this. Again, learn how to use the equipment and practice fieldwork techniques. So data collection methods. There are 2 types of questions that you could be asked for this. Describe how you collect data for the different investigations, asking you to talk about the equipment required and provide a step-by-step guide, and discuss the reliability of different methods, i.e. the strengths and the weaknesses and various improvements. So what I'm going to do is go through each method, tell you about the equipment that's required, and try and pick out any issues to do with reliability, which again was quite hard for coastal investigations to find these questions. So what I've done is summarised it with some questions for you to consider. So what methods do you need to know? There's quite a range. Most common ones are sediment type, size and shape of sediments, the gradient or the beach profile, wave frequency. I did see a question on longshore drift. These are probably associated more with the physical investigations. Other methods that I have seen questions on are infiltration rates, conducting a bipolar survey for the effectiveness and how people judge coastal management techniques to be, questionnaires, pollution on the beach. So these are all the methods that you have to be aware of. So this type draws in nicely to human investigations, rivers for the other methods. So you're sort of applying those things you've learned for the human investigations to this one. But really, I'm going to be focusing more on the left-hand column here. Common equipment, the ranging poles, tape measure, a ruler, a kilometer, clipboard pen, recording sheet, quadrants, stopwatch, calipers, and some sort of scale of roundness. So these are the common methods. And this is what you use the equipment for. So again, if you're unsure, pause this video, please, and just make a little notes and before we move on. So these questions that require you to describe a method, they typically are 4 marks, 5 marks if you need to write a hypothesis. They must include equipment, and you need to describe how you would collect the data from that. Now, you might be given a stimuli, so some sort of figure or an image of them showing students collecting the data that you can use. So again, label that to find out the equipment. And you might be asked to draw a diagram, although I haven't seen this for a coastal question, and really the hardest, the one that you would be required to draw a diagram for is possibly gradient, and I've tried to include that there for you. And structure, if you're really struggling, if you cannot remember the equipment you need to use, just write these points in gold, and particularly for coasts, you might be given some marks, more likely for rivers, slightly harder for coasts, but again, choose a site. Outline how you would collect the data with equipment, talk about repeating 3 times each site to get an average, write down results in recording sheets and repeat at different sites. So if you can't remember what's in black, if you try and write the stuff in gold, you might get at least 1 mark. So like I said, use the chapters in the comments and on the video to go through to the various different methods as you're sitting here with a past paper in front of you, and maybe have a go first, look at the resources, write your answer, use this video to check. Or indeed, if you're really unsure, again, make some notes and try and write that answer in your revision notes that you will remember, but also gets you the marks. The first method, the one that is really common, is gradient, the beach profile, and this is the equipment that you would need. Some ranging poles, tape measure, clipboard and recording sheets, and a kilometer. So looking at the questions here, if you look at them on your screens, you can see they are very similar indeed. And what's useful is that both come with an image of the students collecting the data. So again, you could label that photo, before you go of the equipment that you need, just to help you where the students are positioned, where the various in this particular case, you can see the kilometers being positioned on that line between the white and the red parts of the ranging pole. So again, all this useful information you can include into your answer. Now, a question I mentioned earlier, or a point I mentioned earlier, was what a transect is in beach profiles. Well, here is what a transect is. If you have two ranging poles perpendicular to each other, and that point between them, that line between them, imaginary line between them, is a transect. So you're collecting data along that imaginary line, which you could denote using a tape measure. So if we look at the mark schemes, again, there are lots of similarities between them. They talk about you have to create a transect, you have to make a sort of a fixed distance, you have to use the kilometer, and everything else. So if I were to combine those various points, I would write an answer to look like this. So to measure the gradient, select a site along the beach. With two ranging poles, place them vertically in the sand and agree depth, and ensure they are perpendicular to the sea, with one on top of the beach and one at the bottom of the beach. This creates a beach profile. Use a tape measure to ensure they're 10 meters apart. This creates a transect. Now, the next one's slightly tricky, because if you look at both figures, you can see the person at the top of the beach is looking down, and the person in the bottom image is at the bottom of the beach looking up. Now, I would argue that perhaps the more accurate one, like you do with rivers, is that you are looking uphill when collecting, when using this equipment to collect this data. But again, look at the figure to help you, whereas I would say the bottom one is perhaps the more accurate. So moving on to point 4, students decide a height on the ranging poles. One student holds a kilometer, holds it at the marked height and points it at the same height on the other pole. The angle is read and recorded on the data collection sheet. This process is repeated at different sites along the beach or along the transect. So again, I've included those things about what to include and merge the two mark schemes together. And then again, if we look at the mark scheme, you can see I am ticking all the various points from the mark scheme very easily, very quickly. So though I've written a lot, actually, I'm ticking all those boxes. So very soon the examiner will see, yep, he or she knows exactly what they're doing. So I can award easily the 4 marks. So again, please sit down, include this answer into your revision notes, because as you can see from a variety of past papers, this is what you need to do. If you're unsure yourself, have a go on a different past paper that asks this question, look at the mark scheme, are there similarities? This is what I would do if you were required to draw a diagram and how to label it, or sorry, annotate it, because it's more than one word. So you can see here, I've given you a brief example of what that would look like. So this method explores how to calculate the wave frequency. For this, you need a ranging pole, clipboard, pen, recording sheets, and a stopwatch. So I've picked out 3 questions from a variety of papers. Again, these are all 3 marks, and I've put the mark schemes on the right-hand side. So looking at the mark scheme, picking out some key things between them, you can see there are lots of repetition between them, slight variations in how they're written. But if we look at that and we move on to the next slide, you'll see what an answer that ticks all the boxes from a variety of mark schemes would look like. So if you have a look at my answer, you can see here that I've merged the 3 mark schemes together, and this is what I want to do. So please pause the video, have a little read, see what you think. Mark it. Would you give full marks? Well, certainly within the first paragraph, I've got at least 3 marks of what they require us to do, and I can move on very nicely, and I'm ticking all the boxes there. You could be expected to do a follow-up question, which you're required to calculate the average. And so you can see here for 1 mark, calculate the average of the wave frequency at this particular beach. So as you should know, add up all the wave frequency numbers and divide by 10, because there are 10 sites. That also gives you the wave frequency, and what that means is on average every minute, so in each site the average was 13.7. Another method is working out the sediment type, and so for this you need some ranging poles, clipboard, pen, recording sheet, and a quadrant. Main types of beach sediment that you'd be required to sort of, usually we classify on a beach as sands, pebbles, and what we call shingle, which is kind of like a beach that has multiple sizes of sediment. So there's just some images there just to show you what we mean. Pebbles are nice and rounded, whereas shingle might not be rounded. It might be some jaggedy rocks, very angular, also mixed in with some sand. So how to do this? Well, again, here you can see this what a quadrant is. This is taken from a particular question. Describe how the students use a quadrant to collect the results. Suggest one problem of classifying beach material into sand, shingle, or pebble. Although this is an evaluation question, I threw this in there because it was just nicely associated with this question. So again, here, with two ranging poles, create a transect. At each site, put the quadrant on the beach. Count the number of squares of the different types of beach material. Record the data on a recording sheet. Repeat this in different places at each site to calculate the average. Look at the mark scheme. Yeah, ticking all the required responses there. And then likewise, beaches contain other materials like seaweed. For why it's a problem, yeah, you can see in the image there's some seaweed. Other material that might not be classified because I'm only looking at sand, shingle, or pebble. And again, here you can see some issues collecting this type of data that you, again, might want to include into your notes. Another method is sediment size and shape, and this is very similar to a river investigation. So again, there's a little bit of overlap there. You need some ranging poles, clipboard pen, recording sheets, some calipers, or you could use a ruler, and a scale of roundness for this. I quite like this question because it shows you again how you would select sites for this, beach sampling sites, and also it shows you how you go about recording and collecting this data. So if we go through the first bits, this is the figure from the question example of pebble measurement again. So this tells you the width, the length, and the depth. Nice for this, it gives you a scale. You've got this, and this is actually on there. That is an 8 centimeter ruler. So that's this. On this figure, 8 centimeters, you can use your ruler to do this because it's 1:1, scales 1:1. So if I put my ruler up against this, you can see it's 7 centimeters. The width is 6.5. And so I'm going to write that information in there as 65 millimeters and 28 millimeters. Now, I think there's a mistake with this mark scheme because if you look at it, and calculate the average of the three measurements, add them together, divide by 3, it gives me 54.3 millimeters. The reason I say that I think there's a mistake with here, because on the mark scheme they write it down as 71 plus 65 plus 28 is this, whereas we got it slightly differently. So I think my answer is correct, and there's a slight error with the mark scheme. So how would you collect this data? I really like this question because it looked at how you can use sampling methods as well. So what I'm going to do is just talk about the first question, show you the mark scheme, and then move on to the second question, and then show you the mark scheme. So for the first one, at each site, to make it reliable, I would create a transect line using two ranging poles set at a distance of 10 meters apart, and then a regular distance along the transect. Every meter, I would pick up a pebble. This way, the same number of pebbles we picked up at each site. And you can see here how the various different methods would help you. So again, if you're unsure, include the different methods in your notes. So you might have 2 or 3 ways of collecting this data. And so you can include the sampling techniques there. And so for the second question, describe a method to measure the size, the length of each pebble the students collected. So using a pair of calipers, that's one mark, that's the tool. And looking from above, measure the longest length in millimeters. There we go. You can see there that this is exactly what you need. And so again, very simply, I've put loads of points there in one sentence, so to easily get my full marks. Nice one here, looking at index score for when you look at the measurements of the roundness index, using the roundness index. So again here, how would you calculate it? You times the two together. So 1 times 3 equals 3, and I've used the example to help me with that. So keep on going. Give them a total index score of 24, and then I would have to, so I got 2 marks for that. So again here, 2 marks. And then how would I use the roundness score to how would this make me less reliable? So again here, instead of using the calipers, I would actually go about just picking it up and comparing that pebble against the roundness index and writing that score down. But why might this not be very reliable? Well, really, so sorry, just to recap, I've put the method here about how you would go about collecting this information. So again, you might want to include this. But an issue with the roundness index, really, it's very subjective, whereas measuring the long axis uses calipers is more accurate, it avoids human error. So again, this is what this is the mark scheme. It's giving you 2 points. So please do pause this video, rewind it, looking at why this data might not be very reliable and how you go about collecting this data as well to include into your notes. Another method you're expected to know is how to measure longshore drifts. So you need a ranging pole, a clipboard pen, recording sheets, a stopwatch, and some paint. Follow-up questions about describing the methods to investigate longshore drifts and what equipment would you use. And again, this has appeared twice. Just to recap, this is sorry, not that it hasn't appeared twice. I've taken this back from a previous section about how to go about collecting the process of longshore drift. What this is, because this is really important. You would select a range of pebbles and paint them in different colours. You would use a ranging pole and place it vertically in the sea. This is the start. Place each of the coloured pebbles into the wave swash, and then leave them for a period of time, for example 24 hours, and then return to the beach to find the pebbles and measure the distance from the start point and how far they have travelled. Record distances on a data collection sheet and take an average of all the distances. And so this is the method that you would do. Please do pause the video and include those into your notes, because it is a tricky one. I've only seen this appeared once, but this should help you in case you don't know how to approach it. Another method that I've seen is looking at infiltration rates, and so I've included this step-by-step from an exam paper that of how to measure the infiltration rates for a coastal investigation, and also you can see a diagram as well associated with that. But I took that from a rivers paper, but you can kind of see how you would go about setting it up. And again here, describing the field method to compare how tourists may have polluted the two beaches. So again, this links into other methods that you might have seen for human investigations. So I'm just going to show you the mark scheme now, and the type of things that you might want to consider. You could use quadrants, you could pick up tally, you could take photos, you could do a bipolar index. It's entirely up to you. So here again, just pause the video, make some notes, try and link it to other investigations that you have seen. And again here, some other methods. You've got a questionnaire, bipolar index, okay, so you can see what that sort of thing would look like. And so, a question here came up, describe how the students could make the results of the bipolar survey to make sure they were reliable. And so I've given you some ideas here and the mark scheme. So really, just to show you that although there is methods specific to coastal investigations, such as beach profile, sediment size and shape, there are other methods that you can link into perhaps more human investigations, such as questionnaires, bipolar index. So again, don't just study coastal isolation. Do study all of the methods, think about how they link in, and that's why understanding the methods and how you go about collecting the data and common issues is really important, hence this video. So please do, if you do appreciate these videos, subscribe and like. I mentioned that there are there's some more styles questions, evaluation style questions, where you look about the reliability, the weaknesses, and how you can improve. Like I said, I haven't really seen too many of these methods, these questions, sorry, but I've given you some. I've sort of shown you as we've gone along the way with data collection methods. But these are the types of things to consider. Have you collected enough data? Is there an alternative method? Did weather conditions play a factor? Was there human error in collecting the data? Were there human interferences along the beach? And is an opinion? Is what you're collecting an opinion? So obviously, if there's an opinion, people's opinions change. These are the types of things to consider when looking at the reliability of a method. And for this investigation, or for this entire paper, across 2 questions, you would get 12 marks looking at data presentation. So there are a range of techniques where you have to go out and you have to complete a graph from scratch. And really, this is practice, practice, practice. I will be making another video, or you can see the link in the video here. They're looking at the common data presentation techniques and how you go about doing that, so thinking about what you need to do. So please, as you're completing a past paper, use that video because it will just take you through it a little bit more. Really, if you can see here, there are loads of different ways that you can show the data, and it's really important that you practice with past papers. It's really hard. I can't go through every single past paper. I haven't got the time. You do need to practice. Now, here you can see something that is very unique to coastal investigations, and that's a triangular graph. You might have seen these for maybe industry questions from paper 1 or 2, tourism maybe, but for here you can see this is for coast, looking at how you plot data to show the material beaches X and Y. So how do these work? Let's take an example. So let's use the first one here at beach X, 80, 15 and 5. So you've got along the sides of the triangle, you've got the various different axes for pebbles, shingle and sand. So if I was going to look at sand, it's 80%. I'm going down the right hand side because that's what it tells me to do with the arrow. And so I'm going to draw a line from 80 going downwards, and you can see that crosses with 1. For shingle, I am looking at the bottom one, and you can see here that the lines go diagonally up. And so I find where 15 is, that's halfway between 10 and 20, and I draw a little line, a faint line. And then just to confirm, pebbles, again, it's 5%, so that's halfway between 0 and 10, the left-hand side of the triangle going up. And where those points meet, I arrive at 1. So if I'm going to plot the answer for 25, I need to go 40, going down, 35, and then 25. And where they meet in the middle, I'm going to put my X and I'm going to put a 2 because that's what they tell me to do. And you can see here, yep, for 1 mark. So this is quite annoying for 1 mark, but it's something you need to practice. So please do pause, rewind. If you're unsure, go through all the other examples. You can see here, I've given you the date of the past question when it was published. So please do print that out and have a go yourself. I've given you another one here, so you can see how it's relatively common. Need to plot, so we'll go through again 84, 10 and 6. So you can see here 84 just slightly before halfway, 10 and 6. And so where those meet, there is 2. So if I'm going to plot point 1, I'm going to have to go 88, so that's just almost touching the 90 line, 12 and then 0, and where they meet, that is my point 1, and I'm going to copy exactly what they expect me to do. Another one, you might be asked to put the line of best fit between some data, and so making sure that goes relatively halfway, relatively equal numbers either side. So data presentation techniques. There is so much variation, it's really hard for me to put loads of videos together. I have tried to give a video, as I explained earlier, of the common techniques. So please do, as you're completing past questions, do use that video if you're unsure. Do not miss these questions. You'll see with past questions, they can be sort of hidden between a whole variety of texts and graphs and tables. Do look at examples before you start doing yours, or calculate it and copy exactly how they've done the examples for you. Use a pencil and practice. So data analysis questions, these again are very straightforward if you know exactly how to structure your response. So you've got 2 questions here, typically worth 4 marks. Read the question carefully. What is the hypothesis trying to prove? Does the question state if the hypothesis is true or not? If it doesn't, look at the data to decide if the data proves that the hypothesis is true, partially true, or false. If it is true, partially true, or false, that is the first sentence you will write. Hypothesis 1, hypothesis 2 is true, partially true, or false. That is always 1 mark. Then you find and write evidence to support your view. So you have to use evidence. 9 times out of 10 you do. And so please make sure you do. And so whenever you say, this is because from site 1 to site 3 there was an increase in the data, show that with data. At site 1 it was this, and it had increased to this by site 4. And as you can see here in the mark schemes, again, 1 mark for telling me if it's true or false. And again, heavily emphasizes massively the use of data. And again here you can see slightly different way of writing this. I wanted to throw it into you. Refer to the results in table 2, but do not copy them out. So sometimes they do, annoyingly, make you not want to write a hypothesis with data. So how do you do that? So you have to use words like majority, most, etc. So the majority of people are aware that the cliffs are being eroded, should be protected, and that a lot of money should be spent. Popular method is groins. So again here you can see 4 marks, 4 statements of how to do this. So over to you. This video was general guidance on how to approach a coastal investigation. In this particular exam paper, I do think practice makes perfect. So please watch the other videos to find out more about the different investigations in a lot more detail and how to approach different skills, and particularly for data presentation techniques. If you have enjoyed this video, please like it and please subscribe and share it to your fellow students. Thank you ever so much.